Welcome on my presentation for dbapresents.com. This time I will show you a little about full text search engine in SQL Server 2012. On the internet and YouTube you can find some presentations about this, in how it works in theory, what it does, what you can do in it. I will show you how it works in practice. I will start with installing it, configuring, and will finish on using it for a simple case, just to show you how it works in practice. Just a few sentences what it is. Full text search is an optional component of SQL Server. It is a very powerful component. It allows for linguistic searches. It's much more powerful than like statement in where clause in your queries, because for like you can search for exact phrases or exact words. So using like statement you can search for exact phrase, but a full text search engine uses thesaurus files, synonyms, phrases, similarities. So it's more focused on how languages are constructed, and use this knowledge to improve search results. With installing full text search component, at the beginning I will make sure that I will check if I have it already installed or not. I can do with querying for server property, is full text installed. In my case it returns 0, which means it is not installed. So I go to Microsoft Download Center. You can find this link in the description or on my website dbapresents.com, in the article dedicated for this topic. So I click download, and here I have a few different files, installation packages. I need a 64 version. So this one is very basic. Full text is not included. This one is SQL Server Express. Additional features are there. Here is with tools. SQL Server full text search engine is included only in this installation package. This one is the biggest one, 1.3 gigabytes, but this is what I need. And I click next, and the download process starts. Once it is downloaded, I execute it. When the installation files are extracted, installation center window appears. I go to installation section. First link is new SQL Server standalone installation, or add features. This is exactly what I need to do. Add a feature. I click it. And the installation wizard appears. I click next. Now it is installing setup files. I haven't decided anything regarding installation yet. Now it asks me to tell installer what I need to do. First option is perform a new installation. This is not my option. My option is to add a feature to an existing instance. Dev SQL 001 is the one that I want to add this component to. So I choose this one, click next, and my full text component is this one. You can see it's not checked. It means it is not installed now. So I check it and click next. I click next again. This screen is about accounts. I'm not going to change anything here. And next again. And the installation is going. And it is installed. Now I'm going to try to verify, to confirm it is installed. So I rerun the query for. I received 1, which means full text component is installed. Next step is creating structure and populating with sample data. So I need to create a table. I create full text catalog, index, and then we can play with some queries. Now I will create a table. I will create a table with articles from my website. This table will contain ID as a primary column, title and content. Title is varchar column and content also. Let's create it. We can see. You can see it is this table and these columns. Now I will populate my table with articles downloaded onto my laptop. Those are HTML files. I will load content of them to the database. It's loaded, and you can see how it looks. So here is the title of a page of article from dbpresents.com, and here is content. Now when my table is populated with data, I need to create a full text catalog. This is the name of the catalog I'm going to create. This is a new name. It's created. And now to use search text engine for searching, I need to create an index. This syntax consists from mandatory create full index on phrase. Now name of the table goes, and here on the list between parentheses I put a list of columns that are going to be indexed with language ID. It says to SQL Server what language and which rules from which language should be applied to those columns. So title is in English, 1033 is ID of English, content is the same, also English. Now there is a key index phrase and primary key name of the table that is going to be indexed. So if we go to dbo.articles, you can see primary key is pk articles. So this is why it's here. On and catalog name of the catalog. And the last option is change tracking. It's set to auto. Change tracking is it says how SQL Server should react on changes on the data in this table. So if I modify modify a row, it says it must be automatically the index must be automatically updated. There is also two other options. It can be manually updated. Then you can have a job run periodically to update the index. This is auto, so just after the change you should see the result effect on the results of searching. So now I'm going to create this index. It's done. You can see it here. Storage full text catalogs dbpresents.com. If I click properties, you can see details. So accent sensitive, it is true, set to true, but it's not default catalog. Those options doesn't matter for me in this case. You can see that this catalog contains one table, DB articles as expected. Unique index is PK articles. It's all correct, and the table has full text enabled. Columns that are being indexed are content and title, and both use English as a language. And statistical semantics is off. As you can see, here are here's the area where you can change, modify, change tracking options. It's set to automatic. And now it's time to query some data. Functions that can be used for querying data. I will start with contains function. Here's an example of use this function. So I do select asterisks from DB articles, where contains is the function provided by full text component. Here I specify which column is being searched, so it's content, and here is a phrase, word, or logical condition even that I'm looking for. So if I execute it, I receive 3 rows, 3 articles fulfill this condition. So this is a simple match. It works exactly like clause dbcc. It should provide me the same result. Content should provide me the same result. Yes, it does. So why we use for such simple case full text? Full text search is much more powerful, but even in this case, the first option, using full text search, in most cases is much faster because it's well indexed, and this where clause with like and phrase that starts with percentage sign is very slow. But contains function provides much more flexibility. For example, I can use logical conditions like it contains dbcc dbcc word and not check db. So it means I want articles that contains dbcc but not check db. So as you can see, one row is off. I can also search for full phrases, also exact match, like I am interested in SQL query phrase, but this one will not work because this is not a correct condition. So I could say I want SQL and query. words. I got 4 results, but I'm actually interested in the whole phrase SQL query. One phrase. It exists only for one article. Let's find it. SQL query. Yes, it is here. Let's do some more complex. I'm looking for DBCC check ident articles, and nothing is found. But I know that this is not true. For some reasons, I'm not getting results. Maybe because there is some actually. Okay, I can use near function to say that I'm interested in those two words that are close to each other in an article. And now I got the result. Let's see how it actually looks in my data. Check ident, and here is the reason. I was looking for DBCC check ident phrase, and nothing was found because there are some HTML tags between those two words. So to find such cases, I'm looking for DBCC word that is close to check ident word. So this is what near function does. It actually also can be replaced with like keyword, something like where content like percentage DBCC percentage check ident. And actually in this case I need to do also, because near in the default usage it doesn't respect order of those words. So if I would like to do the same, get the same results, I would need to, without a full text search, I would need to do it this way. I would like to show you one more usage of contains function. I'm looking for articles with detached about detaching database. So I'm looking for something like detached, and nothing is found. Nothing is found, but actually there can be other forms of detached keyword. It can be detach, it can be detaching, something like this, and I want to include all of them. To do it, I need to use forms of function. I put inflectional keyword and detached. If I execute it, I get got results. Let's see what's inside. Detached. Of course, nothing is found. Detach, and you can see there is detaching word in the article. So there was running this query, I got an article that didn't contain detached keyword, but contained detaching word. So this is how forms of function works. It's very useful, and it's very hard to achieve with like clause. So there is a pure advantage of full text search. Contains function is quite a selective function. There is also a freetext function, which is more flexible and generally returns more results. So we can simplify the previous case by saying find me anything that you can match to detached, but it's fuzzy matching, so return me anything that might be good for this answer. So as you can see, an article was returned without saying that we are interested in inflectional forms. Freetext by default searches for inflectional forms also. And there's no need for logical predicates like and, not, or. We can just type a list of words or even whole phrases here, and something will be returned. So there's, as you can see, list of results is quite good. It's quite big. It means all those results, those articles contain any of those words, including inflectional forms. So it's freetext is quite a fuzzy search. And last function that I would like to show here regarding freetext search component is freetext table. And as you saw, we've got many results. 5 out of 7 rows that I have in my database returned, so it's it's about 80-90% of my database is returned by querying by providing such those 3 words. So it's pretty big. But what about sorting? If there are 1 million results, I'm not going to get them in random order. I want to get them in the best, so to fit my needs. So I want the best matching articles first. So here comes a freetext table function. It needs to get table name as the first parameter, then column name that is indexed by full text search, and there is known by us already a phrase or list of words. It can be joined it should be joined with the main table, articles table, by key. Key is the same as our primary column in the articles table. So this is how the whole query looks. And results returned are exactly also 5 results, but we have one important column that is also is very needed here. It's rank. So you can see that 4 rows has 0 rank and 1 is 204. It means that this row is much more important for the results than the other. So I could actually order by this column in descending order, because the higher rank is, the more matching result is. I'm sorry, not key but rank. I meant rank. So this is the result that the most suits my need. I have a better case even. I'm interested in articles that list DB's size, and if I use this sorted by rank in descending order, you can see that I have an article, find the biggest database on an instance. This article answers my question best. Then there is other, and those results are pretty less relevant. So I can say that actually I'm interested in the best three results of my query. This is how full text search component works in a very short presentation. There are many more functionalities, much more functionalities, much more ways of querying, but I think it gives you a good overview how to install it, configure, and use. More information you can find on Microsoft website. I hope I will have some more articles on my website also. And enjoy if you are going to use this component. Thank you.